Okay, let us discuss this problem 1.278. So this is a quite good problem. So let me read the problem. So this says two horizontal discs rotate freely about a vertical axis passing through the centers. So there is a axis and we have two horizontal discs. So this is disc 1 and I have another disc, let us say this is disc 2. So this is my disc 1. Both may be equal or both may not be equal, that is not given in the problem. This is disc 2. Both are rotating freely about the vertical axis. So this is also rotating, let us say this is also rotating, free rotation about the vertical axis. The moment of inertia relative to the axis are I1, I2. So this disc has moment of inertia I1 and this disc has moment of inertia I2. Angular velocity of these discs are omega 1 and omega 2. Basically omega 1, omega 2 are given as a vector. Let us assume this is the sine of omega 1, this is the sine of omega 2. The upper disk fell over the lower one. Both discs began to rotating after some time. Now this upper disk falls over the lower discs. So what will happen if the upper disk falls over the lower disk? This disk is here and now this disk is also here. So two disks are basically touching to each other. So if you see from this side, that is from side view, will look something like this. So this is one disk you will see and this is another disk you will see. Are you getting it? So if you see from the side, you will look something like this is your axis. So this is axis of rotation and this is the top disk, lower disk, that is bigger disk, disk 2, and this is your disk 1. If you see from the side, you can also make the same diagram something like this if you wish. This is your lower disk, this is your upper disk. Are you getting? And both are now, let us say, moving. So question says when the upper disk fell on the lower one, both disks began to rotate after some time as a single whole. So what is happening? Initially both are moving with angular velocity. This is omega 1, this is omega 2. Now they fall on each other. What will happen if they fall? Let us try to think what will happen. There is a friction force that is acting between these two. So let us say if this is higher, this is lower omega 2. So this will start to decrease. So what will happen? There is a friction force between this surface and this surface. So if this is moving forward, so if this is, let us say, if the top one has omega 1 is higher, so if omega 1 is higher, the lower will apply a friction force in this direction so that the velocity of this will reduce and this friction force will act throughout the disk. Are you getting? So there is a friction force that will act to decrease the omega. And Newton's third law says on the lower disk there is opposite friction force that will act, and this friction force will try to increase the omega. So if omega 1 is greater than omega 2, if this is the case, then friction force will act in this direction so that the velocity of omega 1 start decreasing. So omega 1 will decrease and omega 2 will increase. Are you getting? And a time will come, both will have same angular velocity. Let us say the same angular velocity is omega. So after some time, both disks are moving with the same velocity. Because this is decreasing, this is increasing. A time will come when both angular velocities are equal. At that point of time, both disks will move as a system with same angular velocity. So this means due to this friction forces, so I can write due to friction forces, after some time both disks will move with the same velocity. Are you getting? Both disks will move with the same velocity. Move or rotate. Now let us say this same velocity is omega. Are you getting? Now what can I do is I can apply angular momentum conservation. There is no external force acting in this system, only friction force is acting, and this friction force is basically internal in nature. So I can apply angular momentum conservation. Are you getting? Even if you see the bait, this bait passes through the axis, the bait of moment of bait or torque due to bait is 0. So I can apply angular momentum conservation. So if I see, and let us say after this movement, both are moving again in the same direction. So after this, when they are get combined, again they are moving in this direction with angular velocity omega. So sine of omega, direction of omega is same as the previous omega. So now I can apply angular momentum conservation. So let us write angular momentum conservation. I think all of you have done this problem. So if you apply angular momentum conservation for this problem, what you will have? So initial angular momentum of this disk is I1 omega 1. So let us say angular momentum of this disk is I1 omega 1, for this I2 omega 2. And the final angular momentum is, now moment of inertia will be I1 plus I2 and into omega. So I can write I1 omega 1 plus I2 omega 2. This is equals to I1 plus I2 into omega. Are you getting? So from here I can write omega, that is the combined angular velocity will be I1 omega 1 plus I2 omega 2 divided by I1 plus I2. Are you getting or not? So this is the combined angular velocity. When they will reach this angular velocity, the system will be basically in rotational equilibrium. Both will have same angular velocity. Now the B part of the question says, so the A part, this is the A part, find out the angular velocity. So this is the part A. Find out the steady state angular velocity of the two disks. Now the B part says, find out the work performed by the friction forces. So B part says to find out the work performed by friction forces. So in the part B, I have to find work performed by friction forces. Are you getting? So let us say find work performed. So part B says find out the work performed by the friction forces. So we are interested in work by friction forces. I think first part you have copied. Work by friction forces. Now this you can find it out. Can anybody give me how can I find this work done by friction forces? Give me just idea. Just think. You see what are the forces that is doing work. Initial system has some kinetic energy, finally system also has some kinetic energy, and there is a change in kinetic energy, and this change in kinetic energy must be work performed by some forces, and there is only one force that is doing work, that is friction. In this system there is no other force that is doing work. So I can say change in kinetic energy whatever we have is same as work performed, because only one force that is doing work, that is friction. So this is the work done by the friction. So if I simply find change in kinetic energy, that will be enough. So what is the change in kinetic energy? So half, because this is only case of rotation, half I1 plus I2 omega square, this is the final kinetic energy, minus initial will be half I1 omega 1 square plus half I2 omega 2 whole square. Now plug the value of omega, you will get the answer. So if I plug the value of omega, half I1 plus I2, and the value of omega is I1 omega 1 plus I2 omega 2 divided by I1 plus I2, this raised to the power 2 minus half I1 omega square, omega 1 whole square plus half I2 omega 2 whole square. Are you getting? Now I do some manipulation. So if you do some manipulation here, let us take half common. So we will have I1, I2 goes. So we will have I1 omega 1 plus I2 omega 2 whole square divided by I1 plus I2 minus this half I have taken common. So I will have I1 omega 1 whole square plus I2 omega 2 whole square. Are you getting? I think all of you are able to understand. Now let us say I1 plus I2 as LCM. So if I take I1 plus I2 as LCM, so I will have I1 omega 1 plus I2 omega 2 whole square minus I1 plus I2 into I1 omega 1 whole square plus I2 omega 2 whole square. Now this will be a half. You see, we will have I1 omega 1 square plus I2 omega 2 square. This term will be cancelled. I1 into omega 1. So this term will be cancelled. Here we will have 2I1 I2 omega 1 omega 2. Rest of the term will be cancelled. And here we will have, so there will be 4 terms. 2 term gets cancelled. This term cancelled. So we will have I1 plus I1 I2 omega 2 square. So minus I1 I2 omega 2 square. This is one term. Then another term we will have I1 I2 omega 1 square. This divided by I1 plus I2. Are you getting? Now if I take I1 I2 common, so I will have half I1 I2 common if I take, divided by I1 plus I2. This is equals to, now we will have 2 omega 1 omega 2 here. 2 omega 1 omega 2 minus omega 2 whole square minus omega 1 whole square. Now if I take minus sign also common, so I will have half I1 I2 divided by I1 plus I2. And this is nothing but omega 1 plus omega 1 minus omega 2 whole square. So this is the work performed by the friction. Are you getting? So let us say this is work performed by friction forces. Now important point, you see the final expression is coming out to be negative. So basically friction has done a negative work. So this is the difference in omega. So even if omega 1 is greater or omega 2 will be greater. So this is simply difference. So it depends upon the difference. If both velocities are equal, in that case there will be no friction will act. So if this means the upper disk and lower disk are basically touching to each other. Initially they have same angular velocity omega 1 omega 2. After combination again they will have same angular velocity. In that case friction will not do any work. Now this problem is the important problem. You see, what are the important points we have? We have one important point. Initially the two angular velocities are not equal. And once you put one disk over the other disk, friction force will start acting. Why the friction force will act? Because the velocity that is higher, the points on the disk that is a higher angular velocity will try to slip over the other. And that's why there is a friction force that will act to reduce the angular velocity of that disk. And the disk that has a lower angular velocity will slip, but it slips backward because its velocities are less. So there will be a friction force that will act in the forward direction to increase the angular velocity of the lower disk, because lower disk has I have assumed lower disk has a less angular velocity. In that case, the lower angular velocity will try to increase and the higher angular velocity will try to decrease. A time will come when this friction force is doing some work, and a time will come when both angular velocities are equal. And after that point of time, both will move with the same angular velocity omega. Are you getting? So we have to find that angular velocity. We can use the angular momentum conservation because there is no external force that is acting, only friction force is acting. Friction force in this case is a internal force. So I can apply angular momentum conservation. Once if I apply the angular momentum conservation, I have to find also the work done by the friction forces. That can be done using change in kinetic energy equals to work done. And if I know change in kinetic energy, I know basically the work done. In this case, the change in kinetic energy comes out to be negative, so friction force is doing negative work over the system, and that's why the energy has to be decreased. We'll discuss the next problem. I think all of you have copied this one. If anybody having missed something,